Okay, today we're going to start our lesson on limits algebraically. This is 10.2. We have a couple of methods in which we can do this. The first one is just a direct substitution. So over here we are looking for the limit as x approaches 3 of this expression here. Once you go ahead and you're actually able to substitute a value in, you can drop your limit notation. So we're going to be looking at 3 squared plus 3 times 3 plus 5, and when we evaluate that we get a grand total of 23. Again, I want to do my limit through direct substitution. I'm looking as x approaches -2, we will place -2 in for both x's. So -2 squared plus 1 over -2 squared minus 1. When we evaluate this, we get 5 over 3. Over here, we're looking at the limit as x is approaching pi. Again, pi is just a numerical value, which means we could drop this limit notation. So I'm looking for the cosine of pi over pi, and remembering from our trig unit, pi was sitting over here at the coordinate -1, where cosine is our x, so we're going to wind up with -1 over pi. So that is our first. That's the easiest method, so if you can substitute, I would definitely try that first. Over here, evaluating, we have more complicated expressions. It may be easier to factor and solve them first. And you'll notice here 2, if I try to put 2 in for this x over here, it would drive the denominator to 0. So we can't use the direct substitution, so we're going to factor, and then we're going to try to substitute in our numbers. When we're factoring, we need to carry the limit notation until we get to the substitution part. So the top will factor into x plus 2, x minus 2 all over x minus 2. These cancel here, and then we're looking at the limit as x is approaching 2 of x plus 2. At this point, I'm ready to substitute in. We can drop our limit notation. We get to 2 plus 2, and we get a total of 4. Over here, again, if I were to substitute 4 in, it would drive my denominator to 0. So I'm looking at the limit here as x is approaching 4. If we factor the top, we're going to get x plus 6, x minus 4. On the bottom, we're going to get x minus 4, x plus 2. The x minus 4 factors will cancel, leaving me as the limit as x approaches 4 of x plus 6 over x plus 2. Now I can substitute my 4 in. When I do that, we drop our limit notation. I'm looking at 4 plus 6 over 4 plus 2, which is 10 over 6, which reduced to 5 over 3. One more problem here. Again, if I were to substitute this in, we would drive that denominator to 0, so I'm going to try factoring. We're looking at the limit as x approaches -3. We keep our limit notation while we're canceling things out and factoring. Over here we factor into x plus 9, x plus 3, x minus 5, x plus 3. These guys cancel here, keeping my limit notation until I get to my simplified expression. At this point that I'm ready to substitute in, we can drop our limit notation. We have -3 plus 9 over -3 minus 5, getting me 6 over minus 8, which reduced to -3 over 4. Some of the problems can get a little bit more complicated, but it doesn't really change the way we're going to work this. I'm looking here as the limit approaches 0. 0 would make the denominator be undefined. So I'm going to go ahead, I'm going to wipe out the denominators here and here. Oh, that's a little sloppy. Let's just try that again. One denominator is 5. The other one is 5 minus x. Over here, on the first fractions of 5 cancels, and I'm left with the limit as x is approaching 0 of 5 minus x. Over in the second part here, excuse me, I said that incorrectly. Over here, the 5 minus x cancels, leaving us with just 5. Over here, the 5's cancel. I'm going to put up my parentheses because it's a 2-term and I want to make sure I distribute that negative through appropriately. On the bottom here, since we only have a denominator of 1, all of this will be multiplied to the denominator, leaving me with 5x times 5 minus x. Distributing the negative on the top, keeping my limit notation, I get 5 minus 5 plus 5x all over, let's see, over here, oh, not 5x, I don't have the 5, plus x, all over, let's see, 25x, and that was a minus there, minus 5x. Here the 5's will cancel. Notice I have an x term available in each of the 3 here, so I'm able to cancel out there too. The limit as x is approaching 0, I'm now left with 1 over, let's see, 25 minus 5x. At this point, I've simplified my expression down. I'm able to substitute the 0 in over here. The limit notation comes down. 1 over 25 minus 5 times 0. And I wind up with 1 over 25. Moving on to the back page here. Again, if I could do direct substitution, I certainly would. It'd be a lot easier. But if I tried to substitute this 5 into the denominator, it would drive it to 0, making it undefined. One thing we can try to do is multiply by our conjugates. So I'm going to multiply both top and bottom by the square root of x plus 11 plus 4, square root of x plus 11 plus 4. We're picking the conjugate, so the O and the I or the FOIL will drop in the numerator, keeping our limit notation. Over in the front, we're going to get x plus 11 minus 16. When you multiply a radical to a radical, the stuff inside called the radicand just comes out as is. Negative 4 and positive 4 is negative 16. I'm not going to distribute on the bottom just yet, hoping that maybe something would cancel. Combining like terms in the numerator, keeping my limit notation, I have x minus 5, nice, over x minus 5 times the square root of x plus 11 plus 4. Those canceling there. So the limit as x approaches 5 to get my final simplified expression. I'm looking at the square root of x plus 11 plus 4. Now 11 here. When we go in, we could substitute 5 in here. I'm going to get 1 over the square root of 5 plus 11 plus 4. That's 16, so it's going to be 1 over 8. Let's just try that again with the next problem over here. If I were to put negative 2 in here, this denominator would go to 0. So I'm going to multiply by the conjugate, which is going to be plus 2, square root of x plus 6 plus 2. So now the limit as x is approaching negative 2 of x plus 2 times the square root of x plus 6 plus 2. On the bottom here, we're going to get x plus 6 minus 4. Combining like terms in the denominator. So nothing's changing in the numerator at this point. We wind up with x plus 2. These cancel, leaving me with a final simplified expression. Notice I'm keeping my limit notation of the square root of x plus 6 plus 2. Now that I'm ready to, of negative 2, as I'm ready to substitute in here, I'm going to have negative 2 plus 6 plus 2, give me 2 plus 2, which is 4. For number 10, same thing. If I were to put negative 1, that denominator would go to 0. The conjugate here would be the square root of x plus 4 plus the square root of 3. The limit as x is approaching negative 1. On the top part here, we're going to get x plus 4 minus 3. On the bottom here, we've got x plus 1, square root of x plus 4 plus the square root of 3. Combining like terms in the numerator. So the limit as x is approaching negative 1 of x plus 1 all over x plus 1, square root of x plus 4 plus the square root of 3. These guys cancel. Again, the limit as x is approaching negative 1 of 1 over the square root of x plus 4 plus root 3. I now have a simplified expression. I can go ahead and substitute in. So I'm going to get 1 over, let's see, negative 1 plus 4 plus the square root of 3, which is 1 over root 3 plus root 3, which is then going to get me, let's see, 1 over 2 root 3, and then rationalize, we'd have root 3 over 6. All right, and lastly, we have some properties here with our limits. You can kind of read through them yourselves. So what I'm just saying here is the limit of function f as it approaches some constant is going to give me a value L. The limit here for g of x is going to give me some value, some numeric expression of k. There's a couple of things we can do. If the function is being multiplied by a scalar, we can move that out front and then just at the end multiply what that limit is. Over here, we can separate them out, and I'm just going to kind of show you the rest. You can read through the work. So keep in mind where I'm writing limit notation, you must keep it. If you don't have that, even with the correct answer, you will be marked incorrectly. This one here, I'm looking at a scalar multiplication, that minus 4 I can move out front, times the limit as x is approaching c of g of x, which is exactly what this box is here. I could take this out now and replace it with 6, and I get a final answer of negative 24. Over here, this limit, I could write them as two separate limits, which must be done. So the limit as x is approaching c of g of x, plus the limit as x is approaching c of f of x. Now I could take out this here and replace it with x, and I could take the second one out and replace it with 2. So you get 6 plus 2 for a total of 8. Same thing for a division. We could separate it into two separate limits at first, and then we can do the substitution. And again, we said g of x is 6. The limit of f of x we said is 2. And that would get us a total value of 3. On the last set of problems, we're just changing some of the values for f of x. Now f of x, as the limit approaches here, is negative 4. The limit as we approach some constant here is 10. I'm going to rewrite this as the limit as x is approaching c of g of x, all being controlled by that being squared. I know g of x is 10 squared, and that would get us 100. Again, I'm going to write these two first as two separate limits being multiplied together, times the limit as x is approaching c of f of x. I know g of x is 10. I know f of x is negative 4, giving us a total value of negative 40. For number 16, there are several things going on. We have the square root, which eventually I'm going to write everything here as to the 1/2 power. This negative here is really like a scalar, so it's minus the limit as x is approaching c of g of x all over the limit as x is approaching c of f of x. Okay, so now what we're going to do is just kind of replace things in here. We're going to have g of x is 10, so now there's going to be minus the 1 here times the 10. The limit here is minus 4 to the 1/2 power. That is going to get me positive 10 over 4 to the 1/2. And at this point, I'm not going to reduce this fraction down because I could see 4 is a perfect square. And so that's just going to leave me with the square root of 10 over 2. And with that, we conclude our lesson on limits algebraically.